Cold water that is circulated throughout the building cools the air inside the building. So, the refrigerant cools the water, and the cold water cools the air in the building. For this reason, water is also called secondary refrigerant in chiller systems. Water does not take part in the basic refrigeration cycle. It does not undergo any phase change, but it does cool the air in the building. To cool large buildings, we would need an equally large amount of refrigerant. However, we cannot run refrigerant lines for long distances or through every room inside a building. Recall that some refrigerants are toxic and flammable, so it can be hazardous if they leak. We provide cooling to a large building using cold water because water is cheap and readily available. It's cost-effective to use water. It's not toxic, so leakage of water isn't hazardous. It's generally much safer to use water in place of refrigerants. Chiller systems are also used in applications like ice factories and cold storage, where we need to maintain the temperature below 0 degrees Celsius. Recall that the water freezes at 0 degrees Celsius, so we cannot use water. For such applications, we use brines. Brine is a solution formed by mixing a soluble substance in the water. The soluble substance could be salt, like table salt, calcium chloride, or glycol. By mixing these substances in water, its freezing point decreases. This allows the mixing solution to remain liquid at 0 degrees Celsius. Chiller systems use this cold water to provide cooling to a building. Cold water is called secondary refrigerant. Brine has a lower freezing point than water. Brines are used in applications like ice factories and cold storage to maintain the temperature below 0 degrees Celsius. The main components of cold water cycle are chiller, water pumps, water piping, and AHUs or FCUs. Water pumps circulate cold water to AHUs or FCUs within a building through water piping.